The omega match is an evolution of the gamma match. While a gamma match uses a single series capacitor to cancel out inductive reactance, the omega match adds a second capacitor in shunt that is connected to the ground or center of the driven element. This design provides an extra degree of freedom, making it one of the most versatile, though slightly more complex, matching systems for VHF and HF antennas. In a standard gamma match, you often have to slide a physical shorting bar along the antenna element to find the 50 ohm resistance point. However, if the antenna element is electrically too short or the dimensions of the matching rod are constrained, you might never reach a perfect 1:1 SWR with a single capacitor. The omega match solves this by using two controls. One, series capacitor C1. Like the gamma, this cancels out the inductance of the matching rod. Two, shunt capacitor C2. This capacitor is placed between the gamma rod and the center of the driven element, the ground or neutral point. It acts as an impedance transformer, allowing you to match the antenna even if the shorting bar is not in the mathematically ideal position. Here is a comparison between gamma match and omega match. For gamma match, there is only one series capacitor. Adjustments are sliding bar and C1 series capacitor. Versatility is moderate. Complexity is simple to build. While the omega match has two capacitors, series and shunt. Adjustment, slide bar and C1 and C2. Versatility high, matches a wider range of lengths. Complexity more sensitive to tune. Why choose an omega match? Compensating for short elements. If your antenna is physically shorter than a perfect half wavelength, its natural impedance will be low. The omega match is much better at pulling that low impedance up to 50 ohms than a gamma match. Precision tuning. Because you have two capacitors to adjust, you can often achieve a near perfect match. Broadband performance. While still a narrow band match, the extra capacitor allows for a slightly better fine-tuning across a specific portion of a band. The match is named omega because the schematic layout, with the feed line coming in and splitting between a series capacitor to the rod and a shunt capacitor to the boom, vaguely resembles the shape of the capital Greek letter omega. That is better noted in the diagram by Kilo 7 Mike Echo Mike. Omega match is particularly sensitive to the voltage rating of the capacitors. Because C2 is in shunt, it can see very high RF voltages even at 100 watts. Using high quality silver mica or vacuum variable capacitors is usually recommended to prevent arcing during digital or CW transmissions.